In today's lecture, we will be just determining the quantities of earthwork, okay? Can be in different forms such as cutting and maybe then filling. So we will be just determining the earthwork calculation. Before starting the earthwork calculation, let's just have some basic concept and the method, okay, or you can say some formulas stuff, okay? And then we will just move ahead for the example so we can understand the problem better. As you can see, there can be different methods to determine earthwork calculation, but in these lectures, we'll be just using few methods such as the mean area method and then the mean depth method. So you can say the mean area method, and then we will discuss about the mean depth method because these two methods are used normally, okay? And I believe you guys are just familiar with these two methods. So we will just move very quickly and we will, you can say, give less time to these formulas. Now, what do you mean by the mean area method and what do you mean by the mean depth method, okay? Let's just have some, you can say, filling maybe. Let's say we have this natural surface level, okay? This is, let's say, NSL. And let's say we have some fillings over here, the same way like this, okay? So we have this filling, and let's say if this is maybe embankment, maybe for some filling formation, okay, and maybe just you can say a bank for a railway track, okay. So let's say we have this thing, and it means the section can be the same, okay, to that side as well, such as this one, okay. So the section can be like this one as well, okay. Now as you can see, the section is just trapezium, and this is just normal practice. Okay, so we have, let's just focus on the mean area method first. Now, as you can see, let's say if we have the depth at this section, and I'm gonna call this is D1, and at that section, let me just call this is D2. It means the depths are different, so the areas for both sections can be different. If area of this section, let's say this is just the red shaded area, it means this area is just different than this area, which is just, you can say, the blue area, okay, at both sections. Now, once we have the area different, and if these areas are just the same, it means this is then very straightforward, okay? Then you have to just multiply this area with the length to have the quantity of the earthwork, okay? And we have done this before many times. Now, we are discussing these two things, the mean area and mean depth, because we have different dimensions, okay, at both ends of the same embankment, okay. Now, if we talk about the mean area method, then the mean area method means, let's say, I'm gonna say area, and over here M means the mean area, okay. Now, area at this section, I'm gonna call this is area 1, and for that section, let's call this is area 2. Now, what do you mean by the mean area method? Okay, we have to just multiply the mean area. Okay, and by mean area, I mean just to add both areas. Okay, like A1 plus A2, and then we will divide that by 2. So we have the mean area. Okay, now once you have the mean area, then of course we can calculate the earthwork. Maybe let's say if this is filling, because this is just an embankment. Okay, so it can be filling. It means the area, which is this time mean area, times the length, and this can be actually the earthwork or maybe filling. That's straightforward. So this is actually the basic concept for the mean area method. Okay, now let's just discuss something about the mean depth method. Okay, and again, I'm gonna say, let's say if we have the same embankment, just the same way like this one. Let me just draw it if I can do it better. Okay, let's say we have the same thing. Now, I'm just gonna have some dotted lines over there. Now the mean and one another thing, wait a minute, okay. We're here, as you can see, we have the mean area. And this means that the area of the same embankment at the middle portion, like this one, you can say, just this one. This is actually the mean area. And this means AM. Okay. Now we're here, as you can see, let's say if I have different depths, okay, you guys can hear me, please confirm it.
Yes, sir.
Okay, so let's say if we have two different depths at each end, you can say, and we are talking about the mean depth method. It means the mean can be taken as the middle one like this. Okay, something like this. This depth can be just measured, and let's say this is dm. So the mean depth method, let's say mean and then depth method. So this is actually all about dm, and this should be d1 plus d2 and divided by 2. So this is actually the mean depth, okay, for the same embankment. Now, let's say if we have length of the same embankment as L. Now, as you can see, we have the mean depth, okay? And once we have the mean depth, then of course we can determine the earthwork for the same embankment, okay? Now, the earthwork, and let's say this is just filling again because this is an embankment. So the earthwork can be the mean depth like dm, okay, times the length of the embankment. And this is straightforward and very simple, okay? So this is the main concept related to mean depth and mean area method. Now we will have an example so we can calculate all these things very easily, okay? And one another thing that should be given in order to determine the earthwork, let's say, let me just say if I have the same thing in embankment like this one. So one another thing which should be known is actually uh, the dimensions related to the section, okay? So we should have the depth for both ends and actually the formation width which should be this portion, okay? So the formation width should be known again like this portion, and this is actually B. Now side slopes should be known, like maybe you can say side slope, and this is S1, and for the other another side, let's say this is S2, okay? And these can be the same as well, no problem. These can be different as well, okay? Like maybe these can be S1 for both sides. Okay, now as you can see, we have one another thing which I'm gonna just make it clear for you so we can move ahead then. Okay, if you remember, the areas, if they are different for both sides, and let's say if we have to determine area of the first section, then what should we do then? Okay, let's say this is slope for one side, and here we have slope for another side. You can say S2, and let's say this is just the width or breadth, okay? And here we have the depth, very simple. Now, if the depth is not known, there can be actually, let's say this is formation level, and here, as you can see, this is NSL, okay? So one of, I mean, these two must be then known, okay, NSL. Then, if these two are known, we can just subtract the NSL from the formation level, like you can say formation level minus NSL, and this is actually the depth then, okay? So this is how you can calculate the depth, okay? It is just, you can say the difference of levels. Now, once we have the depth and then the side slopes, then actually what we do, we just split the same section into, you can say, different geometries such as this one, okay? And we call the central one is the area of the center, which is actually what? And that is just BD, okay? Because this is just rectangle. So we have the breadth and then the depth. Now, area of the sides, these are actually triangles. So area of this side should be SD square divided by 2, okay? And this is actually S1. And for this side, area should be S2 D square divided by 2, okay? It means the total area of the same section should be actually area, and it is BD, okay? And that is just BD plus S1D square divided by 2 plus S2D square divided by 2. That's very simple. Now, there is one another thing. If S1 is equal to S2, then we can just simplify this thing a little bit more, okay? And this can be then, of course, area. If these two, if S1 is just S2, then area can be actually BD plus SD square only. So these are the formulas which may required, okay, and which may be needed, okay, in the calculation of cutting fill. Okay, we will just move ahead to the example. And in the example, let's say if we have this embankment, okay, which is actually just 10 meters, and we are asked to determine the quantity or maybe cut fill for the same embankment. As you can see, the side slope are both sides. This is just the same, okay? This is just 2:1. And let's say we are asked to work out the earthwork for the same embankment, but this time by mean area method. Okay. And these are actually the terms. As you can see, we have an embankment and the length is 150 meters. It is just wide is 10 meters at the top, and the side slopes are 2:1, and the depth at each interval. It means, let's say this is an embankment for maybe road, maybe for a railway track, okay? And after each 30 meters, these are actually the depths, okay? You can see them, 0.6, 1.2, these are in meters, okay? And at the other end, it means, as you can see, at start we have 60 centimeters, and at the end, we have the depth is 1.6 meter. So you can say the embankment is just trapezium. Why it's trapezium? Because we have side slopes, okay? And you can label the information just the same way as I'm doing, okay? Now, we have to determine the cross-sectional area is the shaded area, you can say, and then we will multiply this with the length so we can have the quantity. But the cross-section area can be different, okay, after each 30 meters, because depths are different after each 30 meter. So it's not like that. It's not that simple just to multiply area with the length, okay? We're gonna do this thing in a nice table, okay? For this approach, let's say we have the same table, and this table is just known by the mean area method. So the first column should represent the station, and then we should have the depth, then the central area, which if you remember, I have already said that we will just convert the section into different geometries, maybe triangles and then the rectangle. Okay, so the central area is actually BD, and if you remember, it is just the central area, this one. Okay, so this should be BD, or maybe the breadth and then the depth. Okay, and then we should have actually the sides areas, and these are SD square only. Okay, why SD square? Because the side slope for both sides is just, you can say, same. If they are different, then of course we will use SD square divided by 2 for one side, okay? And for another side, it should be S2D square divided by 2, okay? But this time, the side slope is just the same thing for both sides, so we can only use SD square, okay? Very simple. And then the total area should be determined, which is actually column 3 and column 4 summation. And then we will have the mean area. Okay, that's why this method is known by the mean area method. And then we will have the interval, and then of course the quantity of earthwork, which can be in form of cut, maybe in form of fill. This is just an embankment, which is already known over here, okay, in example terms. So it means there will be filling only without cutting. Till this point, is there any question?
Yes, sir.
Okay, you may ask.
सर ये एच डी स्क्वायर ये ट्राइंगल का एरिया है ये फार्मूला.
Wait a minute. Let me just make it a little bit clear, okay? Eh, As you can see, let me just draw the same, maybe one side of the triangle like this, okay? Where here we have the slope, which is maybe you can say S, and on this side we have D, okay? Now, basically what happens is this is a right angle triangle, and you should know the area of a right angle triangle. Okay, remember, as you can see, we have the hypotenuse, that is S, the perpendicular is just D, and let's say the base should be actually SD for the same triangle. So now area of the triangle should be the base times the perpendicular. If you remember, it is just you can say the old thing, and we have done this. Okay, so SD times D. SD is just the base times D, that is just the perpendicular, divided by 2. Now SD, over there we have D times D. It means SD square, okay? And we will just divide it by 2. So this is the same formula. Is it clear now?
Yes, sir.
So as you can see, we have 30 meters interval, okay? It means the station can
Okay, sir.
be, okay, and that is also 150 meters long. This is actually the total length, okay? So it means we can start the station from 0 and tell 150, but the station's interval, that is just 30. So it means 0, 30, 60, 90, 120, and 150. So these are actually stations, and after each station, the depth is different. It is the same thing. If you remember, while making the profile, we make some chin edges, we mark them on the natural ground surface, okay, and then by level machine or maybe total station, we determine the depth at each interval, maybe you can say. So these depths are actually provided by the land surveyor, you can say, okay. So we will just put all those depths, like maybe 0.6, 1.2, and 1.4, 1.6, 1.4 again, and 1.6 again. And those can be just, you can say, written over here in the same table. Now the central area, we will multiply the depth with the breadth. You can say, let's just consider the first station. Over here, we have 0.6 is the depth, okay? That is actually 0.6, and we will just multiply that with the breadth, which is actually 10 meters, okay? The result will be actually the area of the central portion, okay? And but this will be just actually for the station 0, this red shaded area. Now, as you can see, we have 10 times 0.6. This should be actually 6, okay, square meter. And for the another station, as you can see, the depth is different, which is 1.2. So 1.2 times 10, then that should be, let me just remove the other things, these things, so you can see it. So the area can be actually 12, and again 1.4 times 10, that should be 14, and 1.6 times 10, that should be 16, and again 14 and 16 again. Now area of sides, okay, for both sides, area is actually SD square, okay, SD square. Now you have to put values over here, like maybe for S we have 2, and D can be actually different for each station. Let's take 0.6, okay, and that is just square. So this is how you put values in the same formula. Now what should be the value for that station? And this is actually the sides area, and as you can see, SD square. So it should be 2 for S, and for D, that is actually 0.6, okay, but over there we have square. Now this should be 0.72 square meter, okay, we can put that value over there. For another station, the depth is different, which is 1.2. So the answer should be 2.88. Okay, we can put that value over there. Now the depth is just different for each station. Okay, so you can put all these values and just try them by yourself. Okay, and put all these values in the fourth column for area of sides. And these sides are actually triangular. Now total area means just to add column 3, okay, with column 4. Very simple. It means 6 plus the side's area, which is 0.72, okay. Very simple. That's gonna be the total area. And 12 plus 2.88 should be 14.88, and so on. Just do it. Now mean area, this is what we want actually, and that's why the calculation method is just known by the mean area method, because it is we just calculate mean area in the same method, okay? Now again, let me just repeat it. By mean area, I mean just to add one area with another. You can say area of two stations and divide that by 2, okay? Very simple. Like, as you can see, the station 0 and station 30's areas can be added together, and we will divide that by 2. So we can have the mean area for station 30. Okay, very simple. So add all these, you can say the two areas, okay, which are at start or maybe for both stations, and then we will divide that by 2. Okay, and that's just calculated is that one. So that should be 10.8 square meter. We will just put that value, okay, in the same row for station 30. Now, 14.88 plus 17.92 divided by 2, that should be actually 16.4, and so on. Now, we have actually interval that is just 30 meters, okay? That means the distance between two stations, that is just 30. Now, area times the distance, that should be actually the quantity. That is area, and we will multiply that with the distance. So we can have the quantity, okay? 10.8 times 30, that should be the fill, 324, and follow the same process so we can have filling. Now, why filling? Because this is just an embankment. Now, we will just add all these fillings. You can say these things, so we can have the quantity, okay? And that should be actually the total filling of the embankment, 2572.8 cubic meter. Very simple. So that much material is just required for filling, okay, for the same embankment, which is 150 meters long. Now here, as you can see, we have only filling, okay, we don't have cutting over here because the formation level is just above the NSL. In the next example, however, we will include cutting as well so you guys can understand when you face cutting and filling, okay, together. Okay, so let's move ahead for the another method. Yeah, let's say we will just do it using mean depth method. This is going to be the concept. We will be using the same table such as stations, NSL formation level, okay? And the previous, you can say table, the depths were just known. Here, as you can see, depths are not known. However, the NSL and let's say the formation level is known. If the depths are known at each station, you don't actually need to add these things in the table, okay? Just add the depth, very simple, okay? And over here, as you can see, the depth can be actually if you subtract any cell from the formation level, that's your depth actually, okay? Very simple. Now, if the formation level is just a bound, let's say this is the initial, okay, here, and this is the formation level. It means it is just filling, you can see it, okay? However, if the initial, let's say this is initial, and let's say over here we have the formation level, this one, then of course it is just cutting. This should be cutting. And over here, this should be filling. So it's very straightforward, right? Okay, and then we should have depths, and of course, just NSL minus formation level, or maybe formation level minus NSL, okay? You can just switch the location, does not matter. So these should be the depths, and remember this method is known by the mean depth method. So we will add two depths and then divide that by 2, so we can have the mean depth. Then of course, areas, maybe the central area like BD and SD square for both sides, okay? If the slope for both sides, okay, I mean, you can say side slope are different, then of course, you can add another column over here, and we will have SD squared divided by 2 for one side and SD squared divided by 2 for another side, okay? And then as you can see, we should have the total area, and then of course, area times the interval can be actually the quantity, which should be the cutting or maybe the filling. Is that clear? Okay, let's just have an example so you guys can understand better. In the same example, we are asked to work out the quantity of earthwork for a portion of road. We have a road whose formation weight is just 10 meters, the same thing. But here, the things are very different. The side slopes are 1 and 1 in cutting, okay? When there is cutting, we will use 1:1 side slope. However, when there is filling, we'll use 1:2 as the side slope. The natural surface level and formation levels at different stations are given below. Okay, let me just see what we have over there. Again, my pin is not working. Okay, it's working now. Okay, so we have stations such as 0, 30, 60, 90, 120, and 150. And then NSLs, okay, these NSL must be provided by the surveyor, okay, at each station. You can say, let's say this is maybe road portion, and the road has just started from 0, then we have 30, okay, then we have 60, 90, 120, and let's say there is, let's say, curvature, no problem, and then we have 150. Okay, so NSL at this station, at 0 station, that is just determined at 30, at 60 at each station, and they are just noted over here. Then we have the formation level, which is just the workout designer. Like maybe if you just draw the profile of the same road, the formation level is just drawn, okay, and then the maybe the road surfacing or maybe the road topping is just leveled with that formation level, okay, and then we decide the cut and fill based on the formation level. Now, as you can see, the formation level is just above, okay, the value of the formation level is just more than the NSL. It means here we should have filling, okay, again the formation level, it is just more than the NSL, it means filling again. The formation level for station 60, that is more than the NSL, it means filling again. Okay, here the formation level for station 90 is also more than the NSL, it means filling again. Okay, however, look at the station 120, the formation level is just, you can say, less than the NSL. It means there should be cutting, right? And again, at 150 station, the formation level is just less than the NSL. It means cutting again. Okay. So the cutting will start actually somewhere from the middle of station 90, okay, and station 120. So here, okay, on this side we have actually cutting maybe, and on this side we have actually filling. So in the same example, we are facing cutting and filling at the same time, okay? And this point where we actually, let me just draw the map, let's say, okay? If we have this thing, such as this one, okay? Let's say, just a minute, if I can just remove this line, and let's say if we have the formation level, okay, well here we have the formation level above the NSL, but at the, okay, at the end, as you can see, the formation level is just down, or you can say below the NSL, okay. The green one that represents NSL, okay, this one, and this guy represents the FRL or maybe formation level. Very simple, okay? It means we're here, we should have filling. This portion is just filling, okay? And this portion that is just, you can say, cutting. Very simple and straightforward. But here is a point, this point, where we don't have cutting and filling as well, okay? Their cutting and filling both are just 0. This point is just actually known by the intermediate point, okay? IP, intermediate point. Intermediate point is actually a point where we don't see any cutting and filling, you can say, okay? Or you can say the FRL is just crossing NSL, or maybe NSL is just crossing FRL. So here, the things are actually a little bit different. So let's just move ahead to the calculation. And in the calculation, let me just have the same table. And here the section for cutting portion, okay, where the side slope is different, and the section for filling portion where side slope is just different, which is 2:1, okay. Very simple. Okay, so we have RDs, which is 0, 30, 60, 90, 120, 150. Okay, I have left this cell, okay, blank, because I already know that there is intermediate point. Then we have Na cells. Remember, these things were known, okay, Na cells. In the formation levels, these were also known previously if you just saw it, okay. Now we have to determine the depths at each interval. And for that, we will subtract Na cell from FRL, okay, very simple. Like maybe you can say 252, which is the FRL of station 0. We will just take that and we will just subtract the NSL, okay, which is 251. And that's going to be the depth, which is actually 1 meter. And again, 251.8 minus 250.9, that's going to be 0.9. Okay, and so on. Just do that. So this is the same process. We're here, as you can see, when we subtract 250.8, or you can say when we subtract 251.2 from 250.8, that's going to be minus 0.40. And that indicates that there is actually cutting, okay? That minus sign represents the same thing. And again, minus sign for 150 station, it means cutting again. Now we will just determine the mean depth, and if you remember, mean depth means just to add two stations at the, you can say the depths of two stations, and then we will divide that by 2 so we can have mean depth, okay? So just add those two stations depth and divide that by 2 so we can have the mean depth for station 30. And again, 0.9 plus 0.7 divided by 2, that's going to be 0.8. And then again, 0.7 plus 0.6, that's going to be 0.62. Now, one thing which is very tricky and you can say technical word here is actually the intermediate point. How do we locate the intermediate point and what should be the station? I mean, intermediate point is somewhere between 90 and 120 station. But where is it? Is it at station, you can say 95, or is it at station 110? Okay, we exactly don't know the location for that. That's why it's very important to calculate the location of intermediate point first, and then we can move ahead, okay? So as you can see, let's just represent that graphically so you can understand it better more. Let's say this green line is actually the formation level, and you can see the NSL, okay? Now here, these points which are circled, they are just known by the intermediate point because there we have actually no cutting, there we have actually no filling, okay? Let's say, as you can see, we're here, this is actually just filling. You have to fill here, okay? And these places, you can say these red shaded should be just cut out, okay? These are actually cutting, okay? And for the black one, these are actually filling, okay? So this is actually the formation level. Now next, as you can see, we have the intermediate point and that should be determined. And how do we determine that, okay? For that, the distance of IMF, which is intermediate point, should be actually the uh, depth at last station, which is station 90, and we will actually divide that by the same depth, okay, which is the depth at station 90, okay, and we will just add the next depth, which is actually 0.4, and then we will multiply that with the interval, and actually we will just add the last station, okay, and this is going to give me the intermediate point, which is 108. That means the station, which is 108, the cut and fill over there are just 0. Okay, this is very simple and straightforward. We don't have NSL over there, we don't have FRL over there because we are not calculating that. They are not needed. Okay, and the depth over there is 0. And 0 depth means that no cutting, no filling over there. Okay. Okay, so once we have actually the intermediate point, then of course we can calculate the mean depth for station 180 and station 90, okay? And that's gonna be 0.3. Again, the mean depth for station 108 and 120, that should be actually minus 0.2 and so on, okay? Once we have the mean depth, then of course we can calculate the sides areas or maybe the central one as well, okay? And that is
Sir,
actually
repeat this. The distance of intermediate point.
Okay, just let me just go a little bit back so you guys can understand it. Okay, the intermediate point distance, that should be actually the depth of last station, which is actually the depth of station at 90, and that is 0.6. We will just divide that by the same depth. Okay, and then we will add the next depth, which is actually the depth of station 120, and that is actually 0.40. We are not just actually including that minus sign because we are looking at the depth only. And this is the same thing as similarity of triangle, okay? The same way as we determine actually the point of counterflexure. If you're a little bit familiar with these, maybe structure analysis, okay? And then we will actually multiply this with the interval, or maybe the distance between two stations, and that is actually the distance between station 90 and 120, so it's just 30. Okay, and then we will add the last station. Why we are adding last station? Because if you don't add last station, then of course that's gonna give me the distance. This formula is gonna give me the distance from 90 onward. Okay, we are adding the distance up to 90 because we are calculating the intermediate point from point 0. Do some math so you can have actually the intermediate point. Is it clear now? All right, so BD, that's actually the central area, and that's very straightforward. Okay, P is already known, which is 10, and that should be actually the depth, which is 0.9. So 10 times 0.9, that's gonna be 9.5. And again, for station 60, 10 times 0.8, that's gonna be 8. 10 times 0.65, that's gonna be 6.5. Now 30, 0.3 times 10, that's gonna be 3 only. And minus 0.2 times 10, that's gonna be actually minus 2 and minus 6 again. Now SD square, okay? SD square. For S, we're gonna put 1 or maybe 2 because we have cutting and filling both, okay? And over here, as you can see, we have cutting. So for these portions, we will just include the side slope for cutting, which is actually 1. Okay. And for the above portion, we will just include the side slope for filling, which is actually 2. In the previous example, actually, it was just the same thing. Okay, one side slope for both. Because over there we had actually only filling. Okay, this time we have both things, cut and fill. Clear? Okay, so for station 30 SD square by S, we will just put the side slope of the section which is in filling. Okay, and we will just multiply that with the mean depth, and we will have actually square. So simple, and that's gonna be 1.8. How 1.8? Again, let me just repeat it. We have actually SD square. So put 2 for S, and then D, that is actually 0.95, and take it square, and that's gonna be actually 1.8 square meter. Is it clear? Yeah, it's just straightforward and very simple mathematics, okay? You can also do this thing in Excel. In Excel, that takes very less time, and I actually share those Excel file, which I have already made and videos are already uploaded, okay, on the same channel, Engineer Boy Official. Okay, for next station, we have actually the mean depth, and then the side slope again the same, and the area should be 1.28, and so on. Okay. However, after the intermediate point, we have actually cutting. Then, of course, we will just use the side slope from the section which is in cutting. Okay, and that's actually 1. So the area should be 0.04, and for the last station, the area should be actually 0.36. Now, summation of area means just to add those two areas, we can have actually the summation of area. Okay, and I'm gonna do that very quickly. Interval is just known, which is 30 meters. Now area times the interval, that actually means the quantity. Okay, and that's gonna be actually in cubic meter for cut and fill both. So that's 339 cubic meter. Okay, up to station 30. And then we have actually for the other station, which is 278. Again, we have 220. And then we have actually 57. But after this, as you can see, up to 108, which is station this guy, and the quantity is 57. Over here, we have actually all these things, these are in filling. Okay. After this, we have actually cutting, which should be just the area times the length, which is 12 meters. And here is one trick, okay? Because 90 and 108, actually, this is 108. We will subtract 90, so it becomes 18, okay? And that's actually the interval. And after 8, up to, you can say, 120, that should be then 12 meters. So 12 meters times 2.04, that should be 24. And next again, we have 30 meters again, and the area is 6.36. So if we multiply that, we're gonna have 190.8 cubic meter is the cutting. Very simple and straightforward. If there is any question, you guys can ask them.
सर ये 108 आरडी पर ये 57.24 कैसे आया है? ये तो इसमें न कटिंग है न फिलिंग है, तो किस तरह quantity आएगी?
एक सेकंड, मैं जरा इसको शो करूँ तो फिर मैं आपको आंसर दूंगा। अच्छा, सवाल दोबारा पूछा, क्या पूछा आपने? 108 पे क्या?
108 आरडी पर ये 57.24 क्वांटिटी किस तरह आई?
वेरी गुड,
इसमें
वेरी
न
गुड।
कटिंग है न फिलिंग है।
एग्जैक्टली, एग्जैक्टली यही तो पॉइंट है। देखे, 108 पे हमारे पास ये 57.24, ये जो फिलिंग है ये एग्जैक्टली उस पॉइंट पे नहीं है। ये तो असल में स्टेशन 90 और स्टेशन 180 के दरमियान जो जो डिस्टेंस आ रहा है ना, 18 मीटर का डिस्टेंस है भाई। तो 18 मीटर में इतने क्यूबिक मीटर का फिलिंग होगा ना।
जी जी सर।
तो सॉल्व हो गया आपका क्वेश्चन।
जी जी साल हो गया। और ये फिर 108 से 120 तक ही फिर कटिंग होगी
एग्जैक्टली,
24।
एग्जैक्टली, क्योंकि इंटरमीडिएट पॉइंट के बाद कटिंग आ रहा है।
जी जी सर।
चलो, गुड हो गया। अच्छा, 50 मिनट हमने इस चीज़ को डिस्कस किया, तो मेरे ख्याल से इतना ही काफ़ी है। नेक्स्ट वीडियो में फिर इंशाल्लाह हम देखेंगे चीज़ों को। ठीक है, अल्लाह हाफिज़।